So today we are going to talk about Splunk's new Observability Suite. Before we start, I need to put up this slide about forward-looking statements. Some of what I'm going to be talking about is looking to the future at possible directions that Splunk may go. Not all of these products are fully released yet. Not all of them are going to necessarily come to fruition, but we always have to say that. But yeah, let's get stuck into what we do know and see what we can say about it. So just to explain about the purpose of this session and what we're aiming to get from it, we're going to look at answering the following questions. Firstly, what is observability? What do we mean by that term? Is it really something new and shiny? Is it just a buzzword, or does it actually have a little bit more substance? Linked to that, why do we need it? How does it differ to what's already out there? And then we're going to look at the solutions that Splunk provides in this area. So firstly, what is observability? Well, at its most fundamental, at the most basic level, it's the ability to see what a system is doing. Okay, that's achieved through instrumentation. There's nothing new about that. We've had logs and metrics in systems since the very earliest systems that needed to be debugged and deconstructed. What's happened, what's gone wrong. We need instrumentation to tell us that when things go wrong. So we have that observability uses that instrumentation to provide the insights to aid monitoring and drive alerting. So what do we mean by instrumentation? We're talking primarily about metrics, logs, and traces. Some of these will be things that are very familiar, some of them less so. An observable system enables you to understand systems behaviors so you can more easily navigate from effects to cause. So it gives you all of the tools to manage root cause analysis, get to the root of the problem quickly and effectively, get to your impacting your mean time to identify and your mean time to resolve. So we mentioned monitoring there, and you might be saying, well, I already do this. I have monitoring in place. It's comprehensive. It tells me when things go wrong. It might alert me to that as well. And that's all great. That's all part of this, because monitoring is a key part of observability, but it's not the whole picture. And when we talk about observability, we're going rather beyond that. So we've said already that a system has to be observable to be monitored, but monitoring is part of what we mean by observability as a whole. So when we talk about observability, we're looking to find the unexpected things and explain why it happened. Whereas with classic monitoring solutions, we're keeping an eye on things that we know can go wrong. One example might be something like disks running out of space or very high network latency. These are things that we know can go wrong, so we monitor them. But with observability, we're trying to find things that we don't know about, the, if you like, unknown unknowns or the known unknowns. Unforeseen problems versus predictable failures. Deviations from optimal performance rather than out-and-out failures. Dynamic thresholds, dynamic conditions rather than static ones. We need both. We need to be monitoring for those known problems as well as the unknown ones to provide context-based alerting. And alerting is really the key, accurate alerting is the key to bringing down the mean time to resolve to improve resolution of scenarios, incidents that impact your business. So basically both are needed to form an effective support strategy. So we've talked about what observability is. So what's changed to mean that we need to take that step up from monitoring to observability, or expand monitoring to be observant of the whole system? Well, you'll see this cloud journey, the evolution of IT systems it's a very strong trend that's been ongoing now for several years. And current projections are that this is going to become an accelerated driver for change because of competition and also recent times changes to behavior of users of both the workforce and the consumers. Starting on the left, we have primarily on-prem solutions, mostly monolithic, very structured, with tight coupling between infrastructure and applications, slower development cycles, generally speaking, a less dynamic environment than as we move to the right. The cloud journey starts by taking some of those key applications and shifting them, lifting and shifting them into the cloud. And as we're making this journey, you'll see that the development team and the operations team become more tightly connected. So we're now using cloud in the cloud as a service. We have still got some of that legacy on-prem hardware, still got virtual machines being used, but now we've got cloud, both public and private, being implemented as well. But essentially, we've got the same thing in a different environment. As we move further, we then start to refactor. The dev and ops team are getting closer together. And now we have cloud managed dynamic systems, software as a service. Now, I'm seeing this at a lot of clients. There's big applications being moved into the cloud with software as a service providers. The applications are becoming more modular, but still dependent on key app components. Okay, but it's starting to break up. And then we move further to the right, where we're fundamentally re-architecting how these applications are built. It becomes cloud native. In other words, building it for a cloud environment rather than adapting it to a cloud environment. And at this point, developers and operators are one and the same. And we have that DevOps type culture that results in rapid application development, multiple releases concurrently, without the sort of the old build it, test it, release it type scenarios. These things will get released and almost on the fly. Some organizations are releasing thousands of updates to their applications a day. So we've moved in this cloud journey from our very locked down, say monolithic systems based on on-prem hardware, right through to loosely coupled microservices, serverless functions in the cloud. Now, different companies, different organizations will be in different places on that journey. And that's fine. What we can do is support every phase of this transition. And the great thing about the tools that Splunk has built, they're offering, is that they build and scale with this transition. So with these changes, what problems now need to be solved? What you can see on the left here is this sort of cycle. And it's an endless cycle of development. It's not a phased development anymore. It is a continuous cycle of improvement. And with that, what that creates rather is a new set of problems to solve and a new dynamic timescale to solve them, because often these things are live. So we need to monitor the cloud infrastructure. We need to be able to investigate log data. We need to be monitoring application performance. We need to be aware of what a user's experience is and how that's being impacted. And we need to have a SRE DevOps incident response capability. And on the right, you've got all of the things that come with that. It's a complex system. massively interdependent, tens, hundreds, even thousands of microsystems all coupled together. It's more unpredictable. It's very dynamic. As it scales, as it gets larger, it expands and expands. It becomes increasingly difficult for any one individual or small group of people to have full insight into everything. I quite like this phrase at the end here, troubleshooting becomes a team sport. Very much so. Okay, all the different teams need to have access to key information to be able to troubleshoot when things go wrong. That's what we look to provide. So what does this mean? What are the challenges this actually presents us with? So if things aren't going well, if we don't have all these things in place, we can have outages impacting users. And this isn't like in the old school way where a server is down, we have an outage. That doesn't count as an outage anymore. An outage is a degradation of a service, of a process. Okay, users have very little patience, unfortunately. So even if something becomes slow, that counts as an outage. It doesn't necessarily have to be non-functional. It's just, it impacts the user experience. Therefore, that's similar to an outage. We want to be able to deploy faster. Okay, we want to be able to make those constant improvements. That means we want that deployment frequency to go up. That also increases developer productivity. But if this isn't done well, or we don't have the instrumentation and the visibility to be able to monitor and observe these systems clearly, we're going to get failures. We're going to have ineffective incident responses, and it's going to start costing us money. So those are our pain points. The business impact is all linked. This is all interlinked. Customer experience is being impacted. Can't keep up with competition. Can't meet our SLAs. Aren't achieving our business KPIs. Not reaching our targets. People aren't happy. But that's okay, because we can fix it. How is Splunk going to address these challenges? Well, that is where the Splunk Observability Suite fits in. A single, tightly integrated user experience. Bring everything into one place to simplify, streamline, and make more effective support in all of these complex new environments. On here, we have 5 of the key components. I'll mention a couple of other newer additions, but these are the 5 key ones we're focusing on today. We have Splunk APM, Application Performance Monitoring. Splunk Run, that's the real user monitoring part. Splunk On-Call manages alerts, and if you've been following Splunk and its tools for a while, that was previously known as VictorOps. Likewise, Splunk Log Observer then is based on Splunk's own core technology, and then Splunk Infrastructure Monitoring. Splunk Infrastructure Monitoring and Splunk APM were previously SignalFX, purchase that Splunk made a couple of years ago, but it is much more than that now. They've taken those core elements and expanded on them, and now we have this much more comprehensive tool. So just looking at each one a little bit in turn, Splunk Infrastructure Monitoring. With this, although it's a cloud-based solution, we can monitor on-prem infrastructure. We can monitor your VMware environment. Public cloud providers as well, AWS, Google Cloud, Azure, are all covered. We can monitor serverless environments and Kubernetes and container environments as well. All of this is now part of what Splunk can offer. Previously, aspects of this, elements of this could be covered, but now this has brought it together as a much more comprehensive tool. Then we have APM, Application Performance Monitoring. This has been a bit of a gap in Splunk's tooling, in the products that it offers. With the acquisition of SignalFX a couple of years ago, and the developments they've made since then, they really are now providing all the different elements. And what I meant to mention on the previous slide, we go back to our metrics, logs, and traces, the 3 key components to make up a complete observation suite. Application performance monitoring is all about the traces. Within your code, you embed the traces that are going to tell you what's happening within your application, how long different steps are taking, what steps are taken within the application, and with full fidelity collection of this data without sampling, the Splunk Observability Suite gives you access to all of the information, all of the user traces that are collected or generated, I should say, by your applications. That becomes key to having a comprehensive tool for identifying problems effectively and quickly. Real user monitoring ties into the same concept. Within your applications, you embed traces that will report back on what the steps within that application are doing, what steps are being taken. So real user monitoring takes that information, helps developers understand and optimize that user journey. It's key to understanding impact of release changes as well. Okay, as I was saying before, the development cycles become much more rapid. Okay, it isn't always feasible to test every single change that you're making. So with canary pushes to allow you to distribute your new code out into a production environment, but only to a subset, you can see the impact, use real user monitoring to see what that impact is. And if there are negative impacts, then we can resolve that. So full fidelity transaction monitoring that allows you to completely understand the experience of every single customer. Remember, no sampling. This is every trace is recorded and kept for analysis. And then the Splunk Log Observer. Notice that this is in beta. Might sound a little bit familiar. It is essentially tying in the core Splunk product into the observability suite to allow you to review the logs associated with those traces and metrics being collected elsewhere, to bring it all together into one place to give you that complete picture. The Splunk Log Observer is, if you like, an accelerated or simplified version of the Splunk core product. And it's entirely cloud hosted, and it has a number of pre-built out-of-the-box integrations, and those will continue to expand. Now, I don't know how long until we get Splunk Log Observer, but it'll be very interesting to see how that develops and evolves over time. I know that a huge amount of work's been going into this, so it'll be really interesting to see that in action. And we'll be seeing that a little bit later in the demo. And the kind of final piece of the puzzle here is, in order to provide comprehensive support, you need an effective alerting tool. And Splunk On-Call, which was previously known as VictorOps, allows you to manage and maintain lists of people who are on call at any given time, manage those groups so that all you need to do is say, I need somebody from this team, and this will work out who the right person is to contact with escalations and all the rest of it. It integrates with Okta, Jira, Microsoft Teams, and additional functions can be included as well. And we'll see a nice example of a virtual war room in the demo coming up in just a moment. And we go beyond that as well. Now, these are recent acquisitions, so it will take more time for Splunk to bring them in-house, and we'll go back to my earlier disclaimer about future-looking statements. But Plumber is an expansion of the APM capabilities. Rigor offers synthetic monitoring tools, and I believe is actually available now. Very interesting from my point of view, because I've often been asked by customers for means of using Splunk for synthetic monitoring. It can be done. but this will definitely simplify that process. So that's a very exciting one for me. And Flowmill takes network performance monitoring capabilities and adds that to the mix as well. So we have networks as well as applications. Really is a comprehensive set of tools when it's all been brought together, but not just yet. Okay, so how does it actually work? How does it all work together? So I'm going to go through a demo. Now this is a pre-recorded demo, so in that sense it can't go wrong, so that's good. But I won't speak too soon. Anything can happen with a demo, even a pre-recorded one. So I'm going to switch to the demo now. It's going to take us through a sort of scenario, a real-world scenario, showing how all these different tools interact in order to provide a realistic view of what an incident response might look like using Splunk's Observability Suite. So I'll start by giving you a little background on what you're going to see here. Our fictional demo company runs an e-commerce site and recently refactored it to go cloud native by using microservices for the application architecture and containers for the underlying infrastructure. The team that keeps the site up, the SRE team, are out for a team lunch. That's something we'll hopefully be able to do again soon, along with commuting and all the other joys of office work. So in this scenario, they're just finishing their dessert when Jenny, the SRE on call, gets paged. Jenny knows that the alert is worth paying attention to because the alerts are all backed by the reliable and intelligent analytics of the Splunk real-time metrics platform. She pauses the conversation and looks at the message from Splunk On-Call mobile. The alert shows that the number of purchases in the past hour has dropped and the checkout completion rate is abnormally low. She knows it's truly an outlier because the alert logic takes into account the time of day and week as a dynamic baseline rather than simply using a static threshold. To investigate further, she heads into the office and logs into Splunk Observability Suite from her laptop. She wants to begin by first understanding the impact of this alert she just received on the users. She goes into the real user monitoring view to see if there are any clues on problems that have occurred in the front end in the web app. She notices two issues that may be related to checkout problems: a spike in the number of JavaScript errors and high backend latency. She decides to probe further, as at this stage it's not clear if the two are related or if they're causing the problem that she's noticed. She starts by taking a look at the endpoint latency and notices that cart checkout is experiencing some huge latency. She clicks on it. On the right panel, she can see that there have been some spikes and they're related to the fetch operation. Clicking into one of the exemplar traces shows that the latency isn't a front-end problem, but needs to be tracked into the backend. Luckily, with the tight integration between Run and Splunk APM, Jenny can click on the APM link to preview what's available to her. She could even follow the traces all the way through because she has access to full fidelity trace data with Splunk Observability. To make sure this isn't a single outlier, Jenny clicks on the workflow link to see the aggregate behavior of this important transaction in their system. The performance issue that Jenny sees associated with the user action leads her to check out the full set of services backing the checkout in the APM. By just looking at the service map, she identifies that both the payment service and the data store that backs the cart service have errors that are identified by the system as root cause errors. In other words, the services with the most downstream errors contributing to a degraded experience. So, switching to the on-call incident war room, she adds the payment service and the card service teams to the incident, as well as in addition to the SRE team that she's part of. Since Splunk On-Call handles all on-call schedules, she doesn't have to worry about which team member receives the alert. She knows that someone is going to get paid. This brings Sarah, the cart service owner, and Andrew, the payment service owner, into the incident, and they go and look at their respective services. Sarah starts by keying in on the Galactus Postgres 98321 in the service map. Postgres is a commonly used open source data store that backs multiple services inside the company, and it runs on Kubernetes. She wants to know if there's anything correlated with the errors being seen on the data store, so she selects it. Sarah goes to the bottom of the page to see information that's related to this service, like what infrastructure it runs on, what alerts it has, whether there are any error logs associated with it, and so on. She decides to check on the first item, just to eliminate infrastructure problems as a source of issues. When she does that, she doesn't notice anything out of the ordinary. There was a code push, so the pods running on the server are relatively new. But everything seems to be within normal bounds, and the error messages she's seen don't indicate anything that would explain the high latency. Meanwhile, Andrew is looking into the payment service, a custom microservice that's been instrumented using OpenTelemetry, the new standard for unified metrics, traces, and log data that Splunk is a leading contributor of. Thankfully, even without having to dig into individual traces, Andrew can see an aggregated trend in the errors. He notices that most of the errors are from the production environment. He can dig deeper by clicking on the tag spotlight, which takes advantage of infinite cardinality to see how his requests and errors are distributed by each tag and value. This not only allows him to identify the root cause, but also get a feel for the radius of impact. Here, the versions point to a problematic deploy, and it seems like all tenant levels are affected. He can now narrow his investigation to the version of the code and dive deep into a specific trace. With Splunk's full fidelity approach, Andrew is confident that he has had the end-to-end trace when he needs to dig deeper. Andrew now notices a trace that is showing unexpected behavior, so he looks for additional information that's being collected while this is going on. Given that we're using OpenTelemetry, all the metadata that he needs to correlate the traces and the relevant logs is available, so he simply needs to click on the highlighted trace ID to look for related logs. In the log view, he sees a number of log lines that relate to the trace ID and notes that some of them are errors. The message indicates that there was a failed payment attempt, but also that the checkout seems to have eventually gone through. To investigate further, Andrew clicks on one of the errors to see the details that are captured in the log line. What he sees immediately makes him suspicious. The failed payment message also indicates that an API token used is invalid, and the name of the token is a dead giveaway. It's a test and not a production token. To confirm his hypothesis, Andrew selects the message, adds it to the file's name, service file's name, clears the trace ID filter so he can broaden this data set to include all of the logs with the message for the payment service. He then switches to Visual Analytics to group by version number, then widens the selected time range. He sees that version 350.10 is correlated with all of the errors that they've seen. Luckily, this is only happening in a subset of the environment, since his company does canary pushes to see how new code is doing before it gets promoted to the environment as a whole. Since there's obviously something wrong here, he decides to revert the code back to a known good state while he hunts down the right token to use. To confirm this is all working, he watches the live tail to make sure the failed payment message present in his logs previously are not making a reappearance. As the code gets rolled back, the errors die down and the latency for the checkout service goes back to normal levels. Andrew doesn't even need to go to another tool to see this. He gets the notification on his laptop that it is cleared. That was a demonstration of how all of these tools come together to provide a comprehensive incident response. Zooming in on the problem quickly, resolving the issue promptly, and reducing the impact on users. So a quick recap, and then we'll finish up and address any questions. The Splunk Observability Suite, observability focusing on three core components, three core types of instrumentation rather: metrics, logs, and traces. Now, just to recap on that, logs has been part and parcel of Splunk since the very beginning. That's what Splunk is known for. Metrics as well, certainly in the last few years, has become a key part of what we do with Splunk. The addition of traces really gives us the full picture of what's going on in any given system that we need to observe and to monitor, to alert on, essentially to support. And this nicely trademarked little strap line here, NoSample everything, refers to the fact that in most APM solutions, in fact, as I understand it, in all other APM solutions, traces are sampled. You don't get every single trace recorded. And that's a key difference that allows us to be completely confident in being able to see and understand the full process end to end. So the sorts of use cases that these tools, these Splunk observability tools, are ideally suited to, and these are certainly not all of them. Cloud migrations, where environments are being gradually moved along that cloud journey I mentioned earlier. Hybrid cloud environments, cost management, with all of these systems that can spin up and disappear in a blink of an eye, keeping track of the costs and projected costs becomes a key consideration that doesn't so much apply with an on-prem sort of environment. Capacity planning as well. So cloud migrations, cloud monitoring. Although clouds, the different cloud providers will provide tools to indicate how your environment is behaving. Being able to centralize that, giving you full visibility in a single location, is hugely valuable to teams that are tasked with managing and maintaining these systems. Includes things like Kubernetes and container monitoring, notoriously tricky to keep on top of, serverless monitoring as well. So cloud monitoring, another key use case. Application performance monitoring, APM, say broadly speaking, a newer area for Splunk, and it really is something that provides that final piece of the puzzle, I think, for full observability of your systems. Covers application modernization as you're making that transition from your on-prem systems to more complex, loosely coupled microservices in the cloud. And we've talked a little bit about this in the context of DevOps style of working. Really, once you get to the point where your developers and operators are essentially the same people, it becomes essential to have the tools that both can use in order to do the job. And then incident response, the demo that we just went through. How do you reduce that mean time to identify and mean time to resolve? How do you improve the on-call experience as well? Making sure that the right person gets called out rather than pulling in somebody who's not available or shouldn't be being disturbed. Key part of what brings the solution together. So how are the solutions provided actually addressing this? Well, as I mentioned, we collect all of the data. Okay, no sampling, logs, traces, and metrics, all of the data. And it's in real time as well. We saw in the demo there, we switched to the live feed at the end, the live tail. You can watch this happening in real time. And it's scalable, massively scalable. These systems are designed to be able to cope with any size of environment. And that's why when you're making that transition, you can be fully confident that wherever you start and whatever steps your journey takes, these tools will continue to be able to deliver what you need every step of the way. And the last bit there, analytics and machine learning. I haven't really touched on that because it's almost a whole large topic in itself. We can discuss perhaps on another webinar, but a lot of what's underpinning these the alerting strategies and the monitoring capabilities uses elements of machine learning in order to fine-tune the responses that have been generated to give you more accurate information, reduce false positives, and just make the whole process more efficient. And from that, we're going to see improvements. We're going to see better customer experience. We're going to see improvements to release quality and speed of those releases. Because if you're confident that you've got the tooling in order to be able to identify problems quickly, you can afford to move more rapidly in the development cycle. That improves development efficiency, and that makes your business more adaptable. And in these last 12 to 18 months, that has been crucial. So, Splunk Observability Suite accelerates your deployment frequency, reduces lead time for changes, minimizes downtime, and improves your system stability. So my personal takeaway from this, having spent quite a lot of time seeing how this fits together and having spent the last 4 years working with Splunk and seeing what it can do, but also where it has gaps in what it can do, it really feels to me like this is getting close to a complete solution for all aspects of your IT support and IT monitoring. So from me, Splunk's Observability Suite provides the maximum data with the tools to fully understand and manage increasingly complex cloud solutions. You have full fidelity, collecting metrics, logs, and traces to provide a complete record of a system's behavior. Okay, well, if there are any other questions, please feel free to contact myself or a member of the Somerford team with any queries you've got at all. I would be more than happy to help. Also, I'd say watch this space. This is an area that Splunk put a huge amount of effort into recently, and it's still developing, and there's still exciting developments coming. As I mentioned, there's 3 additional tools that are going to be brought into the family, as it were. So yeah, still lots to find out, still lots to learn, and there'll probably be more webinars in the future to expand on some of these topics and go into more depth about specifics. So like I say, watch this space and look forward to seeing you again in a future webinar. Thank you very much.